Streaming to all the right places. Royce, so welcome to the Bulk Truth.
Hi, Steve.
How are you?
I'm doing great. Good weekend.
Good. We got a lot of cool things going on at Cadaro. You know, we talk about in this program about all the things that the challenges of measuring bulk materials as they flow through the plant into whatever truck or railroad car or package, whatever you're moving this to. It's a challenge to measure everything, and so you can't manage what you don't measure, and that's what this show is about. So today we're going to talk about an actual application. Where is this machine installed?
So this location is in Conrad, Montana. So just thought it'd be helpful to see that these actually exist, see them working in the real world. And this is really what Cadaro does on a daily basis, is help customers solve problems and provide solutions for how they can measure and ultimately manage what they're doing.
So what's the backstory on this before we start sharing these images and talking about them?
Yeah, so in this specific case, we're looking at a facility where they were needing a solution to unload trucks directly into rail cars. They have a bulk weigher that they are normally using for loading rail, but there's certain grains, certain materials that they don't want to contaminate, and so they're going to utilize the Cadaro flow sensor to measure material flow from the truck into the rail car, and the goal is to hit as close as possible to the targets. And so that's what they were looking for. Originally, they reached out a little over a year ago, and their flow rates are roughly about 6,500 pounds a minute. And previously, our top end of our VERACITY series prior to the launch of the Diamonds was 5,000. And so with the launch of the VERACITY Diamond, we then had a solution that could not only help them achieve the flow rates that they were looking for, but also gave them the opportunity as they continue to scale, we could grow with them.
So what were they doing prior to getting the VERACITY installed?
Yeah, so they would unload part of a truck, go around, weigh it. So they would just keep weighing it until they hit the target for how much they needed on that rail car.
And in the same contraption in between those two, the rail and the I guess the offloading truck.
Yeah, so one of the reasons we chose this as an illustration is the VERACITY Diamond sets between two conveyors. So the first conveyor is taking it off of the semi trailer, and then it dumps into the next conveyor that's elevated up above the rail car. And so that's one of the reasons we chose this, was just because it was a transfer point between two conveyors. And this is what we see in a lot of processing facilities. And so when we're starting to look at where can we fit one of our Cadaro flow sensors, it's at a transfer point. And so this just helps illustrate, this is a loadout situation, but what it will even fit into a processing plant.
All right. So, when my eyes look at this, I'm not an expert from this industry, but I see the typical grain elevator over to the right. And this was a big investment in an infrastructure setup, and obviously they're running a rail. There's a rail spur that comes through here, and they're offloading whatever that material was stored in that grain elevator. But then they had an opportunity to also, I guess, start distributing some other material.
Sure,
material.
Yeah, the growers are bringing different types of grains. Depending on the season. So whenever you're bringing a semi in, so they can unload directly off the semis and load directly into rail. Mm-hmm. The first thing that comes to my mind as I see this is you can see for a long ways. So beautiful drive to Montana and where this location is, and in the background you can't see it, but behind the elevator you see the mountains. So yeah, it's breathtaking as far as the location.
So I'm looking at this this was a nice a smaller investment fix to bring in varied materials and then put them into the existing rail spur process. And so on the right, we have this conveyor belt that extends from, I guess we'll call it the transformer, where the VERACITY is located. It's the green. You see it.
Yeah, that's a transition point. So,
Yeah.
and we'll get a close up in a second, but towards the left-hand side, that's where the VERACITY Diamond's located. And then it goes up the longer conveyor, if you will. In this case, it's showing a picture of a semi. So we use that semi just for the initial calibration,
Yeah.
but it's typically going to be a rail car is located there. And that's what we're helping them load.
And then the truck comes in, then they place that short conveyor from under the truck, goes through the VERACITY, and and we're measuring it so we know when to turn it on and off to hit the exact amount that's going to go in that rail car, where the truck is demonstrating what a rail car would be.
Correct.
All right, so this is a close-up of the setup. So the VERACITY, when you're talking about it, it's just this little bitty box that fits in all these tight spaces.
That's correct. So that's the VERACITY Diamond 14K. So they built a stand that's mobile. So they wanted the ability to move this around. Depending on what time of the year it is, they may move it indoors or to another location. So they built that frame that it's mounted directly to. And so again, just to illustrate, we're at the transfer point. So, and I think maybe the next photo will show the actual the conveyor that's unloading from the trucks, and it's placed right over the top of our sensor.
So before I go to that, I'm kind of impressed that they built the addition. So the VERACITY Diamond is a little. When you guys produce it, it's that little piece that fits in all sorts of unique places that you don't have to reconfigure your whole process.
Correct. That one, without the little hopper on top, it's 12-inch profile. So it fits in a 12-inch height space. And the overall box, the idea of that box is roughly 22 inches.
Wow. Then not only did they configure a mobile version of this, they can move around in different places, but they even painted it the same color.
I love it.
Isn't that cool?
Yeah, everything's first class.
Yep. And so now we're looking at where the short conveyor belt that's coming from under the truck is dumping into the VERACITY. With that, they made that little hopper. What do you call that little hopper?
Little hopper. Yep.
Yep. So it's dumping in there, and then it's going through and being measured accurately within 1%.
Yeah. So I think in the case of this one, like when it was calibrated, is within 300 pounds. So it was like a 0.75% variance versus a scale.
Cool. And so a lot of material can flow through there without slowing down the process and remain or keep the accuracy of the measurement of the flow.
Yeah. So key point is they want to be able to measure. They want to load a rail car where they get the digital readout as far as where they're at in that loading process. And so then they can watch that, and they're manually going to close the gate of the truck so they can hit the target without going over.
All right. So here's a close-up of the top from the hopper.
Yeah. So the internal on this unit is a lined unit, so it has a ceramic liner. And so as the material's passing out of that first conveyor, you can see as it passes over that tinted dome, and we're capturing the pressure on our load cells underneath that dome, and that's what we're translating that load cell signal into real-time flow rate and weight.
So the ceramic liner, tell me the significance of that.
Yeah, so that ceramic liner there is a press-in liner. It's helpful. So as you have more abrasive materials, it's just going to help the life of the unit, just as far as abrasion. And so in certain applications, certain materials, it's very desired as far as its characteristics.
So that little white thing at the very top is measuring the pressure.
Correct.
From this big old hose that's just dumping that material on there.
Yeah, I think that's a 14-inch inlet as far as round. So it's going 14-inch round to 14-inch square. So material passes directly through and escapes out the bottom. I think we have a video to maybe illustrate that.
So you said within 300 pounds. the total pound that's going to go in that rail car is what?
So in that rail car, you're going to be looking at roughly 200,000 pounds. So it'll be rough. It'll be somewhere around 4 semis.
Wow. All right. So now we're going to do the make sure I have the sound down. So here's the video. You can watch this in action. Here we go.
Yeah. So you can see they pull the semi up over the first conveyor. They open the gates, and then they start transferring material in.
So it's flowing. So the only difference in their typical system is the green parts. That's all they did. They had to raise this little short conveyor up a little higher.
So they actually had a longer spout. So I think the heights are exactly where they were before. So they had a longer spout going from the first conveyor down to the base of the second. And so they just shortened up that spout to fit us in. And that was part of the deliverables, finding a solution that would fit within the space that was allowed. Now, granted, they built a pretty solid and sturdy frame for this to mount to, but that's up to the customer as far as what fits them best. And again, the illustration here is just to show anywhere that you have a conveyance point is a potential to fit a flow sensor in to know precisely what those flow rates are. So you can make those either automated or manual adjustments.
Conveyance point. Notice all the dust that's just blowing off of that as it goes through.
Yeah, in a closed system, that would just be captured and pulled right through.
Wow. Or an indoor where some person's having to stand there and turn it on and off. They're getting covered in all of that.
Yeah, this is probably less dusty than most environments. So if you were filling a semi and out in the wind, it'd be a lot dustier than what we're seeing here.
All right, so now we're going to show the next one. So it shows from where the gates are open under the truck and then flowing up, and we're getting the back view.
Correct. And so in this application, it's vertical flow. It's free flowing. So the material's not stopping. It passes straight through. And again, this is not only an application for a loadout process like this. We're seeing these type of conveyance applications not only for rail. We're seeing it for container loading. And so they're looking at adding a sensor to where they're normally it's an overhead bin going through a flow sensor, feeding a belt or a conveyor that's going to be extended up into a container. And so those containers may be loaded with soybeans, mills, but they're going to be loaded and put on a ship and sent overseas.
And this plant, tell us about the plant. What kind of material is going through and what's going on here?
So I believe we're using wheat for the calibration, but this could be being located in Montana. Could be canola, other peas, lentils, so other grains that possibly are going to get loaded onto rail cars. And that's the calibration process. So we'll for the application, for the material that is going to be seen, I think we ran three runs through the sensor to get a high calibration point, a low calibration point, and then a confirmation. And that's how simple the process was. So with the 3 runs, it was dialed in, and Josh was ready to come back to Amarillo, Texas.
It's fascinating. So what has to happen from yard entry to exit? Yes. What happened? I'm sorry. I've got a prepared question here. So what has to happen from yard entry to exit for a loadout to be truly automated, not just assisted? What's the difference in automated and assisted?
Yeah. So in this process, I mean, what could potentially be automated at some point is with those conveyors, you could have a target. And so once it's seen that target, it could, close the gate or stop the first conveyor, right, and clear the system. And so that's how you would hit a target as far as, being precise for the loadout. And so there are facilities, again, similar to this one, that you may start with a manual process. So they're going to watch a digital readout. They're going to indicate when to shut the gate or stop. But down the road, if there's a desire for the automation, it's already built into the system, so they can hook that up and then hook it to an actuated gate and utilize that step of the process.
And then where do you place measurements so the system can trust it? And what does one pass control look like when we watch this rail loading install?
So I'm not sure if I all that question, but as far as placement of the measurement, I mean, really the placement is at that transfer point to know how much material has gone through to be able to achieve a target. And the trust comes from that calibration. So once you get it calibrated and it's proven in, and people learn to rely on it more than the normal process of having experienced operators guessing, or in the case of this, is sending the trucks back around to weigh, to know precisely what they put on the truck and how much more to add. And so we have a facility that's similar. It's got one of our VERACITY integral units, which is set at an incline, loading out of an overhead bin. It's in Goodland, Kansas, but I was there a few weeks ago, and the operator mentioned that sped up their process by 30%. And so they're loading rail cars 30% faster and accurately than versus the way they were doing it previously.
When I'm looking at this, Royce, I'm looking, all right, so this is just sitting out here in nowhere. I don't see any wires or anything, but we're also collecting data. There's not just a little a number gauge on that little box on the side. Data is being collected and transmitted somewhere, no?
Correct. Yeah. So I believe that this unit, the control panel, is located, I believe it's in the same place as where that bulk weigher is as far as their controls. And so it's located in that control room. So it can be monitored from afar, and then they just communicate back to the operator that's running the gates or the trucks.
So we're not just, I mean, the upside here is not just, all right, I know when to hit stop and the rail car is full and it's accurate, but we're also aggregating data to be used in various business processes later as well.
Sure. So, I mean, in this case, I mean, if you have 3 or 4 semis, right, you're going to be totalizing that from each truck. And so we'll have that weight. So if it starts and stops, it's going to stop accumulating. You start loading again, it starts totalizing again. And then when you reset batch, so you go from one rail car to the next, you reset batch. So you'll still have totalized for the day. So if you loaded multiple cars, you can say, this is how much I moved, and loaded for all those cars. And here's how much I loaded on an individual car.
So what applications? So in that case, in my head, I'm going, wow, an invoice could be triggered right away with the exact, and so we're not waiting for this recorded amount to be collected, mailed to us another place that's going to invoice them. There's a lot of upsides. What applications of that immediate picture of the data that we have? What are some use cases there?
Yeah, so our data is going to be more operational data. So where they can know, they'll know what they did for the day, what they did for a shift, for an operator. That's the type of data that you're going to be generating. The transactional data is still going to be coming from a scale, if you will. And so that's the data that's going to be integrated into an ERP system for that automation. So our focus is really on the process itself and helping automate that process and have better KPIs, better metrics as far as performance and how they can improve and be able to measure them to those improvements.
But the sky's the limit on what you could do then.
Yeah, it's very flexible. So it comes back to measuring, number one, having the accuracy and the consistency that you can rely on that measurement, and then from there, what can you do and what could you potentially automate in your processes. So we talk about as far as if this was inline process, you didn't have it where you're taking it off of the truck and putting it onto the rail car. but you wanted to know how much material is transferring at any given time in an actual processing facility. So these sensors, when they're placed, you'll have that visibility to what's happening, even though you can't visually see it. And so if something stops, starting to decline or overfeeding, you're going to see all of those variations in real time.
All right. I'm glad you show and tell today. I'm glad you brought these. These help me. Just, I talk to you about this all the time, but these fill in a lot of details and a lot of images in my head that I guess I was curious about, but didn't know what to think or see.
No, I appreciate that. And hopefully it helps others. I mean, just getting the visual as far as, how others are using the technology, it brings it to life. It's real, it works. And then they get ideas of what they could do or possibly where it could help them. So hopefully we'll be able to provide more of these in the future as we explore how this technology is being utilized and how it's helping people automate.
All right. So we got this great QR code up here in the top corner with the green C, the C behind with the green behind it. You can scan that. That'll take you to the right place to connect with Royce. What are some other ways that folks can connect with you if they're not QR code curious?
The info at Cadaro is a good place to go. So if you want more information, if you want to set up a virtual meeting or in person to do a site assessment, understand, what challenges you're having and where we can help you, that's a good way to get started. There's also a phone number to reach out directly. So if you prefer by phone, just give us a call, and we look forward to exploring how we might be able to help you.
And just to be clear, in as little as 7 days, could have system in place. No?
Yeah. So we are our fastest turn yet. So from the time somebody reached out to the closing and getting ready to ship was a 7-day window. So you moved pretty quick.
All right. Be sure to follow Royce on LinkedIn. You can see his LinkedIn handle here below on the screen. Royce Schulte, just like it sounds. That's Cadaro.com. Royce, I guess we'll see you next week. Another good job.
All right. Appreciate it. Thanks.
Did you ever think you'd grow up talking about Cadaro and Veracity Diamond online? I mean, you run a business. Who thought you'd be like talking on YouTube and LinkedIn, X, etc.?
Yeah. Who would have thought?
It's a legitimate business conversation. People need to know, people want to see. So that's, you'll see all sorts of various examples going forward. Lots of good conversations. Connect with Royce, and we'll see you guys on the next episode of The Bulk Truth. You can't manage what you don't measure. And that's a wrap.